Welcome to Ask and Learn.
Hello students, let's begin with this question. Here we have to find out the concentration of A2 negative, H2A, then HA negative and concentration of H3O positive. So now here firstly the dissociation equation is H2A will be dissociated to form HA negative in the presence of water, HA negative plus H3O positive. So this is for the Ka1 is equals to 4.67 into 10 raised to power minus 3. Then here this Ha negative in the presence of H2O, this will give A2 negative plus H3O positive. So Ka2 is equals to 9.55 into 10 raised to power minus 7. So now here writing down the Ka1 and K2 expression. So this is equals to the concentration of, here we get Ha negative into H3O positive upon the concentration of H2A. So and Ka2 is equals to A2 negative concentration up into concentration of H3O positive upon the concentration of H2. Here we get Ha negative. Then here substituting the Ka1 values and H2A values. So here firstly, here this 4.67 into 10 raised to power minus 3 is equals to, here we get that H3O positive into A negative value comes to be, here this value is, here this is, here this HA negative is equals to 0.1012 molar. This is already given in the question upon the concentration of HA negative. So here this is in the terms of H3O positive is equals to 4.67 into 10 raised to power minus 3 into concentration of H, here is H2A upon 0.1012. Now here for the Ka2 value is the 9, here is 9.55 into 10 raised to power minus 7 is equals to A2 negative into H3O positive upon, here we get 0.1012 molar, substituting the concentration over here. Now here substituting the value of H3O positive in this second one. So here we get 9.55 into 10 raised to power minus 7 is equals to 4.67 into 10 raised to power minus 3 into H2A upon 0.1012, here 0.1012 into A2 negative upon 0.1012. So here after substituting this value, now here rearrange this in terms of the A2 negative. So concentration of A2 negative is 9.55 into 10 raised to power minus 7 into 0.1012 square upon 4.673 into 10 raised to power minus 3 into H2A. Now here, now we have the expression this in the terms of the HA negative and H3 positive. Now here this H3O positive is equals to A2 negative plus 2 H2A. Now here this is equals to 4.67 into 10 raised to power minus 3 into H2A upon 0.01012, 0.010, here is 1, 2, this is equals to 9.55 into 10 raised to power minus 7, then here is 0.1012 square, then here is, this is upon, here we get that 4.67 into 10 raised to power minus 3 into H2A, then here is plus 2H2A. So now after solving this, we get here that this H2A value is equals to 0.0024 molar. Now we get this value. So after that here, now we can find out the concentration of this H3O positive. So here the concentration of this H3O positive is equals to 4.67 into 10 raised to power minus 3 into 0.0024 upon 0.1012. So on solving this, we get here this concentration. So this comes to be 1.1 into 10 raised to power minus 4. Then the concentration of A2 negative is equals to 9.55 into 10 raised to power minus 7 upon 0.1012 square into 4.67 into 10 raised to power minus 3 into 0.0024. So here the concentration of A2 negative comes to be 4.34 into 10 raised to power minus 10 molar. I hope this video is useful for you to understand this problem. Thank you.